Hello, everyone, and welcome to the Math Bender. This is the first lecture of Function series, and I'll try to cover every aspect of it, but this one is primarily about the concept and its basics that we need to know before starting off with functions. Let's start. Okay, so let's say you're staying somewhere at a hotel which charges $10 per night. So, so for one night, it's $10 the room rent. And if you're staying for 10 days, it will become 10 times 10 makes it $100 total. But if I have to take out a formula or if I need to construct an equation which caters to the system that I am seeing right now, for example, the total fare of my stay will be equals to 10 times the number of nights that I spend at the hotel. Now, this is a very basic one though, but this is a system where fare and night they are variables. This could be less nights. So, for example, if you're staying for lesser nights than 10 nights, you will be paying less fare. And if you're spending more time there, then you'll be paying more, obviously. So, this is a basic system. If you, let's say, if you take a cab which has initial rate of $10 before the starting off and it charges $2 per mile. So what is going to be your total cost if you have traveled 12 miles? So now as you see that in this system, the total cost is also there. That's a variable. And miles. This is also a variable. Rest is all fixed. But the problem is the moment you sit in the cab, it starts off with $10 even if you haven't traveled a bit. And every mile that you take after traveling, it will be multiplied with 2. So if you want to write this down as an equation, you can write this as total cost of your travel is going to be equals to 2 times each mile that you take plus $10. So, so if someone asks you rather, what is the total cost of traveling 100 kilometer or 100 mile? So the total cost will be equals to 2 times 100 plus 10, and the cost will be $210. This is also a system, another system, where the variables are joined together to perform it as a function. There are many other examples everywhere that you see around with multiple variables involved. But since we tend to keep it simple, we only take two variables into account in our real life, which is x and y. So everything x and y is only just an interpretation. You can plug in any other variables instead. For example, I could have taken this equation as y equals to 10x. And we are used to of taking it this way. But rather, I took night and fare as my variables. So that is why we are used to of taking y and x as variables, but one side of it is that you're not able to connect it with the real life example. So let's say if we have an equation in front of us, y is equals to 3x plus 2 and you are to, this is an equation where x and y are variables, and you are to draw this on a graph paper. So the first step is, rather than sketching, you take out a box and you take some random values of x. Let's say -2, -1, 0, 1, 2. Now, these are the values you chose yourself. You could have chosen negative 50, negative 40, negative any value depending on the graph grid that you have. So these are, so if you see all the x values, then you chose it yourself. So it is called an independent variable. It is a variable, but it is an independent one because you can choose any value depending on the direction of your graph. And this is dependent. Why is it dependent? Because you can't choose these values. I mean, just if you plug in y equals to 3 times negative 2 plus 2, which gives you y equals to negative 6 plus 2 makes it negative 4. And you write this negative 4 here. So making it dependent on x. And we call y as well as f of x. So f of x is only means that it is a function of x, whatever the values x keeps on varying with y as well. So this is it up till for the basics of function. You represent any mathematical function like this, either f of x like this. You also write it f of, there are so many representations. You can see it like this as well. This is as same as. Now if I say f of x is equals to, let's say, 2x plus 3, what is the value of I'm writing y here, y is equals to 2x plus 3 as well. What is the value of y when x is equals to 3? So what you do is you just plug in straight away. Instead of x, you plug in this value plus 3 and you get 9. The same question can be interpreted in terms of function as f of 3. Rather than I write down the whole statement of finding the value of y when x is equals to 3, I rather straight away write what is f of 3. So it is understood that when this input is instead of x, so whatever that is there in the equation, you place it with that and you get 9. So moving on, how do you classify a graphical? So this lecture is more towards the graphical representation of functions. I will do another one related to the functions jargon and its its way of solve its way of solving the equation. But this is more precisely towards how to view a function when it comes to graphs. So how do you identify? So we have a vertical line test. We have a vertical line test to identify a function, because if that vertical line intersects more than one places on anywhere on function, then we call it that it is not a function. If you see these, all of these red lines are intersecting at only one point. Now, but if I draw the line here, can you see that this intersection is here and as well as at this point? So this is not a function. Now here you can draw anywhere, you can draw here. You will see that this is as well not a function because it is intersecting more than one point. So in order to test whether the behavior in front of you is a function or no, you draw straight away a vertical line to check whether if it intersects more than one point. Now a function is also dependent on, since we already talked about that anything, when we draw any behavior, any graphical representation is there, then we see that it is on the x-axis as on the y-axis. So x-axis, how much stretch it is on the x-axis represents the domain of that function, and how much stretch is it on vertical, it is called the range. So the minimum and maximum value of y are the ranges, and minimum and maximum value of x are the domain of any given function. Now we will see more questions related to domain and ranges, but before that, we need to know a few things. So let's say this line I've in this line, and if I draw like this, so the line started off with the point which is part of that and this. We call this a double-ended because this line has a starting point and it has an ending point. So domain can be represented by looking at the starting and the ending point. So let's say if a comma b and c comma d is the coordinate. So we will say that the domain is a is less than equals to x is less than equals to c, and the range is b is less than equals to y is less than equals to d. Moving on, another variation of this. Now if you see, these are hollow. So domain of this, let's say they have the same coordinates a, b, c and d. So the domain now becomes a is less than x is less than c, and range is going to be b is less than y is less than d because of those hollow holes we don't have. Now if you follow American context, in it you write this domain as a comma c, where the square brackets represent less than or equals to. The same goes with b comma d, and here it's going to be a comma c with round brackets because a and c are not part of our domain, and here b comma d. You can try doing other variations of it as well. Now third thing is, if the function is like this, and this is going to be a single-ended, which means it has a starting point a and b, but it does not have an ending point because it will keep on going. Now the domain becomes x is greater than or equals to a, and if you want to write with another American system, so we say that a comma infinity. Now if you see that a is part of the domain, hence a square bracket, and since infinity cannot be attained with a round bracket, range of this function is y is greater than or equals to b because it is a single-ended. So you write the same way, b comma infinity with a round bracket off. One last thing about it, if this line has no starting, no ending point, so the domain of this function will be x belongs to real number and negative infinity to infinity. Now range as well is y belongs to real number and negative infinity to infinity with both round brackets. Let's see some of the questions here. Now for each of these graphs, you're to state the domain and range. Now if you see this one, single-ended, so it has a starting point and you say that the domain is x greater than or equals to, because that this hole is filled, so greater than or equals to -1. Range is y is less than or equals to 3 because the function is going down vertically. If you still want to look at it like this, this is the starting point and you go straight down till the maximum. So if you see that it is going, it's not stopping. And the same way, domain is on the left or right part. Now for b, it has a starting point but with a hollow and ending point. So domain is going to be -1 is less than x is less than or equals to 5. and range is 1 is less than y is less than equals to 3. If you want to write domain in any other format, it's going to be round bracket -1 5 square bracket, and range is going to be round bracket 1 comma 3 square bracket. Now look at this function here. Now if you see this one, the function exists everywhere except x is equals to 2 and y is equals to -1. This does not exist there. So now the domain of this function is going to be x belongs to real number, comma x is not equals to 2. And how do you write it in any other format? I'll write it down here. So if you want to write it with any other format, it's going to be -infinity, comma 2, 2, comma infinity. Mind you, this is not for the CAIs, Cambridge ones, because Cambridge don't follow this pattern. But this is precisely for people who follow either university calculus mainly or American board. Now moving on to domain, and now for range. Now the range is y also belongs to real number, but y is not equals to -1, and you write it down with -infinity till -1 union with -1 till infinity. Now see, let's look at this question here. Domain of this function, as you could see that it is going here and there. So it does not have a starting point, neither has an ending point. Domain x belongs to real number or -infinity till infinity. The range is, now as you could see, the function is only existing here. The function went up, reached the point which is at y is equals to 2, and then came down and then followed the same path. So which means the range will be 0 is less than y is less than equals to 2. So, and this is going to be 0 because 0 is not a part of it, is comma 2 with a square bracket. For this function, as you could see that the function is not ending, it's going up and right, and on the x-axis it's expanding both ways. So the domain will be x belongs to real number or -infinity to infinity. But the range of this, the spread of this curve, is, as you could see, that this is the minimum point it has attained, and after that it is straight away going upward only. So the range is y is greater than or equals to -1 because -1 is also a part of it. So you write -1 comma infinity. Okay, now for this one, as you could see, if you try to interpret its behavior, the function is moving up, attained a point which is at y equals to 2, and then came down and attained a point which is y equals to -2, and then kept going. Now the arrow shows that it is going, it will not stop. So there is no maximum point. The earliest we were thinking that this was the maximum point, but the function will surpass that eventually. So this maximum point is of no use to us for the domain or the range. So if we see the stretch, horizontal stretch, as we could see that the function will keep on going like this. So the domain of this function is -4 less than equals to x is less than equals to infinity, or we also can write that down as x is greater than or equals to -4. This both are correct, but since infinity, the CA's Cambridge does not prefer writing it down. And now, for I can also write this domain as -4 is a part of the curve, comma infinity. For the range part, the function has its minimum value of -3. So, and it's going up, then there is no stop to it. So y is greater than or equals to -3. -3, we put a square bracket, comma infinity. Can you try this one? You may pause the video, try attempting it, and if you're able to, I'll solve it eventually. So domain is x belongs to real number, comma, but x is not equals to -2, x is not equals to 2. You can also write the domain in this manner: -infinity till -2, -2 till 2, which means -2 and 2 are not part, and 2 till infinity. For the range, same, y belongs to real number and y is not equals to 0. Alright, so the last part of today's session, types of functions. So there are two types of functions. Either it is going to be a one-to-one function. One-to-one means for every one x value, it has exactly one y value. So for every domain, there's only one set of values for range. So now look at this part. You may see this function as like this, a straight line. For this point, if you look at it, it has one x value and it has one y value. There's nothing else there. But if you see a function like this, a curve like this, it has as well, if you draw the axes, you will observe that this value here is x value, this value here is y value. So for one-to-one function, there is another one, many-to-one function, means many x values will correspond to only one y value. For example, you can see a quadratic curve. We will discuss quadratics when we do a lecture series on them, but just giving you an example here. We can see a trigonometric sine curve. All of these values, now look at this part. So at this value, or this value of y, there is this value of x which has the same y coordinate, and this value of x as well which has the same y coordinate. The same goes with the sine curve. So this value is shared by 4x values. So this is how many-to-one function represent. In order to test whether the function that you're looking at is many-to-one or one-to-one, you go with the horizontal line test. And horizontal line test, what it does is that you draw a horizontal line. If it intersects at one point, it's a one-to-one function. If it intersects at more than one point, it is many-to-one function. Let's look at this question. So types of function. I'll just randomly draw this horizontal lines everywhere. So for the first one, it is intersecting at one point, hence one to one. Many to one. This is one to one. Now if you see here, this is many to one. 3 points intersecting. This is many to one because this line is overlapping another line. So infinite points on the x-axis representing that one y value. And here, this is also one to one. So this is it about functions. I just try to cover the very basic of functions graphically. In my next session, I'll discuss functions equation, how to solve, how to approach them. Please do write in comments about your feedback, anything that you want me to work on, explain further. I also have a recommendation of transition of functions. I'll definitely work on that, and I am, but I will post that video in sequence to the function series that I've just started. I'll see you in my next session. Take care. Bye.